Today we're doing section 2.3. It is about writing and interpreting direct variation equations. They are going to look very similar to linear equations, which is what we just got done talking about. All right, on our warm-ups, we are solving the equations for y. So on number 1, we have 12y equals 3x. Can someone raise their hand and tell me what they did to get y by itself? Charles? Divide both sides by 12. Good. That would get y all alone. So on the left we have y. On the right we would want to reduce this fraction to 1 over 4. So you can either write it as 1/4 x, or you could write it as x over 4. Either of those would be acceptable. Number 2. Same thing. We've got 12y equals 5x. Again, to get y by itself, we divide by 12. Will this one reduce? No. 5/12 x, or you could leave it as 5x over 12. Okay, number 3. Ooh, interesting. Well, it depends on which way you want to go about it. So either of you could be considered correct. What would you be, Sadia, what would you do?
I divided the 3/4 by 15 and I got 20. Y equals 20.
Okay, so when we divide by a fraction, what are we really doing? Multiplying by the reciprocal. So that's why either way you say it, technically you can be considered right. So we either divide by 3/4 or we multiply both sides by 4/3. I'll move this over just a little. Okay, so we end up with y equals 20, right? 15 times 4 is 60, divided by 3 is 20. Or if you have a calculator, it can do that for you. Questions, concerns? Okay. On to number 4. This one again, we'll have the whole debate over, is this division or is it multiplication? Okay. Either way, you can argue it. So we would either divide by 9/10 or we would multiply by 10/9. Did anybody get an answer for this one?
Yes, 30.
Just 30?
Yeah. 30x.
Oh, 30x. Thank you. Don't drop your variable. All right, number 5. What did we get?
7. Y equals 7.
Good. So 5y equals 35. We're just dividing. Y equals 7. Questions about 1 through 5 before we do 6 through 9? So, Alexia, what do you think about number 6? Yes. How did you decide that, Alexia? Because why? Wonderful. So 1/4 and 2/8. We know we can reduce 2/8 to become 1/4. So yes, those are equal. Caden, are you helping us with number 7?
Yeah.
All right. What do you think?
True.
Why?
Because divide the 6 over 15 equals 2/5.
Okay, so if we, again, simplify, we could simplify by a factor of 3 to also get 2/5. So yes, those are equal, or it is true. Jacob, are you helping us with number 8?
No.
It's no. Why did you decide that?
Because I couldn't find anything.
Okay, well,
Correct.
your answer is correct. Your reasoning, I'm not sure I'm completely on board with, because what if you just didn't look hard enough? All right, so let's try reducing them and see what happens. Can somebody raise their hand and tell me how they would reduce 9 over 24? Izzy?
Yes. You divide 9 by 24 and get 0.375 to 0.
Okay, so one way of doing it would be to turn them into decimals. I like leaving them as fractions. Ian, did you get it as a fraction?
You talking about how to reduce 9 over 24?
I am.
And you divide it by 3.
Divide both numbers by 3, and what do you get?
You get 3 over 8.
Okay, so that would be the same as the decimal that Izzy mentioned. I'm just leaving everything in fractions. All right, what about 12 over 36? So, somebody raise their hand. So I can talk to somebody new. Charles?
You can reduce it by 6.
Can we reduce it by something bigger than 6?
12.
12. Okay, so that would give us 1/3. Are these fractions the same?
No.
No, so they are not equal. So we would say no or false, or put a slash through the equal sign. All right, let's try to squeeze number 9 down here. Anybody new want to volunteer before I start pulling sticks? It's funny when I say anybody new and then you've already answered and you raise your hand again. Logan.
I said yes because I divided it. It's kind of similar.
What did you get when you simplified your fractions?
I got 10 to the 12.
10 over 12?
Yeah.
Is that all the way simplified?
No, we can do 5 to 6.
Okay, so 5/6. And do we get the same one on this? We should, right? We divide both of those by 5. Then we should get 5/6 again. Oh, that's covered up down there.
You can divide
I
5
actually
by
divide that
36.
by 6.
Could you divide 5 by 6 evenly?
What?
Can you divide 5 by 6 evenly?
I'm talking about 30 over 6.
Oh.
Divided by 6.
Yes, sorry, that's what I meant to say.
What do you
Divide by
divide?
6, we get 5/6. I'm sorry?
What are you dividing 36 by?
Also by 6.
Oh.
I said it backwards when I was writing my
Yeah,
answer.
it was-
Today we are talking about direct variation. It is represented by the equation y equals kx. Nothing added or subtracted. That is not on your notes page. You should add it. It's very important. That's how this is different. Oop, you can't see that. To me, it looks like it's highlighted. To you, it looks like it's crossed out. Nothing added or subtracted. Make sure you include this line. It is a linear function, which means the graph is a line. So we just finished talking about that last week. The letter K represents the slope. K is called the constant of variation and can be found finding the ratio of y to x. In other words, K is equal to y over x, or y divided by x. All right, so first we are going to talk about identifying direct variation from a table. We worked on making tables when we first started graphing lines. Now we're going to be looking at tables to determine if it's direct variation. So we do that by ensuring that the ratio of y to x remains constant. Okay, you can determine the constant of variation and write a direct variation equation for the given information. So we're going to be looking at the ratio of y to x and making sure that that ratio remains constant or the same. All right, I'm going to take away example 2 for a moment so I've got plenty of room. I'll bring it back when we're ready for it. Let's focus on example 1. We need to know if y varies directly as x. So we are looking at the ratio of y to x. That means that y is going to be in our numerator and x in our denominator. Y over x. So what would my first ratio be if I'm looking at the top line? 8 over 2. Can I reduce that?
Yes.
What would it be?
4 over 1.
4 over 1, or you could just put 4. I'm okay with either way. I should have written all of that over here, I just realized.
Why do we have to put y over x?
Because that is the ratio that we are interested in. So I'm reminding myself that this is what I'm focusing on this whole time. Jalen, what would my next ratio be if I go down to the next row of my table? It would be what? So we want y on top. What's my y value? 12 over, the x value is 3. Okay, sorry, I was having a hard time hearing you. 12 over 3, 12 thirds. Again, we should recognize that we can reduce that to 4 over 1. Then we go to the last row. Jacob, what would my ratio be? 20 over 5. And again, we should see that that reduces to 4 over 1. So is our ratio constant?
Yes.
Yes, because they reduce to the same thing every time. So our ratio is constant. That means that y varies directly as x. That means that we can write an equation. So the general form of these is y equals kx. We are looking to replace the k this time. Last week we were replacing m and b, right? This week we're replacing the k. And the k equals 4. We already found it when we were looking at the y over x, this constant of variation. That is k. K equals 4 over 1. That means you can just write it as y equals 4x for our equation. Okay, for number 2, we are going to start it off the same way. We are going to be looking at the relationship of y over x. So, for my first row in that table, Emily, what is my ratio? 4 over 1. Okay, that can't really reduce unless we just write it as 4, so we'll move on. India, what's our next ratio? 7 over 2. Does that reduce? No, it does not. Okay, if you're still wanting to go through the whole process, we could set up the last one. John, what's our last ratio?
16 over 5.
16 over 5. Does that reduce? No. So these are all different ratios. And they do not reduce. They are not equal to each other. So does y vary directly as x? No. So there is no equation to be found. If these are not going to be constant, there is no equation to find. We would say y does not vary directly as x. And in that case, there's no direct variation equation to be found. All right, for 3, we are going to determine if y varies directly with x, and if so, identify the constant of variation. In order to do these, we need y to first be by itself, and then we can decide if it is a direct variation. Okay, so our first step, get y by itself. Nicholas, how would we get y by itself?
Divide by 3.
Very good. Divide both sides by 3. That means that y equals 2/3 x, or 2x over 3. So then we have to decide, is this direct variation? Keaton, what do you think? Is this a direct variation equation? Yes, it is. Okay, we've got the constant of variation multiplied to x. We're not adding or subtracting anything off the end. So we would say yes, it is a direct variation equation. And then the last part is find the constant of variation, which is k. So in this case, Logan, what is k? 2/3. Beautiful. All right, on B, the first step is to get y by itself. So Charles, what are we going to do? Forget. Well, nope, leave the y alone. What should we subtract from both sides? The 2x. Thanks, Charles. I was thanking you for answering even though a bunch of your classmates were trying to jump in, despite the fact that I pulled a popsicle stick.
I used to get popsicles.
I do. Okay, so if we subtract 2x from both sides, this would look like negative 2x plus 3, or 3 minus 2x. So our next step is to determine whether y varies directly with x. Not here. Ajaya, what do you think? No. The reason, because we're adding something on the back of it. If the answer is no, there is not a constant of variation. So we're finished. Y does not vary directly with x. We can just write no. I would need to see the fact that you tried getting y by itself, and that's how you came up with that no, not just a random guess. So if we want to write our own direct variation equation, this is going to be similar to when we wrote linear equations, but I think these are a little bit easier. You're going to write a general equation with all the variables. Just kind of get your mindset where it needs to be, know what you're headed for. Substitute what you know to find k. We've kind of already done this. Plug back in the k value to write the equation. And then answer the given question if needed. So if there's a follow-up question, we would want to answer that. If all we're told to do is find the equation, then we would be finished. All right, let's use those steps. We are told that y varies directly with x. So I can stop right there and say, okay, I know that y must equal kx. That takes care of the step 1 that we just wrote. That's our general equation. And they also tell us that x equals 27 when y equals negative 51. That's going to give us enough information to be able to figure out what k equals. We'll worry about that last line after we're done writing our equation. That's like the follow-up. Okay, so let's plug in our values. Ian, what am I plugging in for y? Just negative 51, right? Equals. Do I know k? No. But I do know x. Quincy is not here. Izzy, what is my x? 27. So remember I said we're not worrying about this bottom line yet. Don't grab this 9 down here yet. Focus on one piece at a time. In order to solve for k, Devin, what would I do? Divide by what? Divide by 27. Very good. We divide both sides by 27. That's going to get k by itself. Whoa, whoa. Okay, so we are going to simplify this fraction. Negative 51 over 27. Those are both divisible by 3. That gives us negative 17 over 9. We have to plug it back in. They asked us to find y when x equals 9. So we can write our equation y equals negative 17 over 9x. But then we have to find y when x equals 9. So we are going to plug 9 back in for x. Lanaya, what do you get when we plug 9 in for x? So we would get that y equals negative 17. If you're wondering how she got that so fast without a calculator, hopefully we recognize that the 9 in the denominator and the 9 we're multiplying with it would reduce to 1. So we really just have 17 over 1. So our general equation is y equals kx still. Y equals 10 when x equals negative 3. So I plug in 10 for y. I don't know k yet. I plug in negative 3 for x. Grace, how would I get k by itself? Divide both sides by negative 3. Wonderful. Again, do not turn this into a decimal. It's a ratio. Write it as a fraction. So then we can write our equation. Y equals negative 10/3 x. Finally, they ask us to find x when y equals 2. So this one is a little different from the last one. The 2 goes in for y. We have to solve for x. So many of your classmates are missing. Caden, how are we going to get x by itself? Okay, so after we plugged in the 2 for the y, we solved for x. We should initially have gotten negative 6/10, but that reduces to negative 3/5. Okay, then let's keep on going. One more problem. A dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly with the amount of time the faucet drips. Find how long the faucet must drip to waste 4.5 cups of water. So, all right, in order to do this, I think it is helpful if we make a little table. So we can consider minutes that it drips compared to cups of water that it wastes. What's the first thing they tell us, like the first line of the problem? Okay, in 3 minutes we waste 1 cup. And we're told that it varies directly. Okay. So if we think about this as our x and this is our y, how do we find k? Do we remember that from the beginning of this lesson?
Oh, 1 over 3.
Y over x, good. So in this case, if I know y is equal to kx, y varies directly with x, then I can find my k by taking y over x.
1 over 3.
So my k is 1 over 3. So y is equal to 1/3 x. I can work with this equation. All right. So then I am asked how long the faucet must drip to waste 4.5 or 4.5 cups of water. So what is 4.5 going to get plugged into? The y. Remember, we set up this table over here. We don't know how many minutes it dripped, but we know we want to figure out how many minutes of drip to waste 4.5 cups of water. So we're going to plug 4.5 in for the y.
What would that be in the fraction?
You want 4.5 as a fraction?
I thought you said it would be easy for you guys.
I mean, in this case, I don't think it's going to make a huge difference, but if you want it, we can make it happen. So 4.5 would be 9 halves.
Or 13.5. Multiply.
Okay, so then to get x by itself, what are we going to do?
Divide by 3/3.
Divide by 1/3, which is the same as multiplying by 3 over 1. Or so we multiply both sides by 3 over 1, or 3. So x equals, put it over here, 27 halves, or that's the same as 13.5 or 13.5. So 13.5 minutes is how long it would have to drip. So if you wanted to leave it as 4.5 or 4.5 instead of writing the 9 halves, you can. Either way, it's the same thing. Same number, different way of writing it.